In this section, we're going to look at solving simple trigonometric equations. So when you're solving trigonometric equations, you need to keep in mind that you're going to get multiple solutions. As we saw in chapter 8, our trigonometric functions had multiple angles that could give the same values. So, there isn't much theory to pick up in this chapter, so let's just take a look at some examples. So we have here that sine theta is equal to a half, and we're looking for solutions in the interval from 0 to 360 degrees. And it's very important that you pay attention to what interval you're looking for answers in. So, if we have that sine theta is equal to a half, then we know this is one of our standard values. We know that theta is going to be 30 degrees. And this is the answer that your calculator is going to give you. But what your calculator does is it just gives you the first answer that satisfies the equation you give it. But we need to find all of the solutions. So to do so, we need to consider one of two things. We could consider the shape of the graph of sine, or we could consider how the quadrants behave. So I will go through both of these methods. So let's start by looking at what the graph of sine looks like. We have something like this, which we saw in chapter 8. So then if we're looking for where it's equal to a half, we're going to be looking about here. So then we get our value of 30 degrees here, and then we have 180 minus 30 over here. The other way we can consider it is by looking at the quadrants. So we have that sine is positive over here, where all of them are positive. Since we're dealing with a positive value of sine, we know that sine is also positive in the second quadrant. So then we're looking over here. So we have that this is 30 degrees, and we know that this angle is going to be 180 minus 30. So then we have that our second solution is going to be 180 minus 30, or in fact 150 degrees. So it's worth writing out each of your solutions like so, and giving the units. So in this case we just had two solutions. In our next example, we need to do a bit more rearranging before we're done. So we're told that sine theta is equal to root 3 cos theta. And we're looking for solutions in the interval 0 to 2 pi. So in this case we're looking to give our answers in radians, but we'll come back to that in a bit. First we need to do some rearranging. So we've got sine theta equals root 3 cos theta. So let's divide by cos theta. And that leaves us with root 3 on the other side. So now we've got theta on one side and our constants on the other. From the identity we saw in the previous section, we know that this is the same as tan theta. So now we've got tan theta is equal to root 3. And also this is one of our standard results. So we know that theta is equal to 60 degrees. Or in fact, since we're dealing with an interval that's expressed in radians, we want to give our answers in radians. So we're looking for pi by 3 radians. So again, we want to consider either the shape of tan or the behavior of the quadrants. So let's start with the quadrants this time. So we have they're all positive in the first, sine in the second, tan in the third, cos in the fourth. Since we're dealing with a positive value for theta, for tan theta, we have our first solution here, and we'll have our second solution here. So our first solution being pi by 3, our second solution being pi by 3 plus pi, which is 180 degrees. The other thing we can do is we can draw a graph of tan, and it behaves something like this. So we can see going across that for our positive value of root 3 we're going to get two answers, and one of them is going to be 180 degrees after the first, or rather pi radians after the first. So we get pi by 3 over here, and then over here we've got pi plus pi by 3. So then our solutions are pi by 3 and pi plus pi by 3, but it's best to simplify your second solution in this case. So then we get theta is equal to pi by 3 or 4 pi by 3. Now, in this case, because our interval was given in radians, it's absolutely critical that we give our answer in radians. As with the previous example, our interval was expressed in degrees, so our answer should be expressed in degrees. So, that's how we can deal with trigonometric equations, and that's how we can look for our extra solutions. So if you're happy with that, then have a go at exercise 10b, or if you're feeling very confident, have a go at these questions.